Welcome back. Today we're going to be looking at how you solve equations. So before we start, I just want us to take a few minutes to review. You do not have to write this information down in your notebook. I will tell you when I want you to write things down. I want to remind you that equations are math sentences that show that two things are equal to each other. So let's take a look at an example of an equation. This is an example of an equation. It says 4 plus 2 is equal to 3 plus 3. Remember that to be an equation, it has to have numbers or variables, an equal sign, and you have to be able to prove that the two sides have the same value. They don't have to have the same numbers, but they do have to have the same value. So how could we prove that these two sides have the same value? Well, the easiest way would be to solve it. So 4 plus 2 would give me 6, and 3 plus 3 would give me 6, and 6 and 6 are in fact equal to each other, so that means that this is a correct equation. Let's take a look at another example of an equation, and this one is 5 plus 3 is equal to 8. 5 plus 3 is equal to 8. Well, if we want to prove that those two sides of my equation have the same value, then I'm going to simplify this one by doing 5 plus 3 is 8. There is nothing to do to this side, so that means these two are equations. I want to remind you of a couple of things. To solve equations, you have to isolate the variable, and that word isolate is very important, so I do want you to write this down in your notebook. To solve equations, you need to isolate the variable. To isolate means to get it by itself. So if we want to isolate the variable, we want to get the variable by itself. Well, the only way to get rid of everything that goes with the variable is to get rid of coefficients. And you remember, coefficients are the numbers that come before a number that's being multiplied, like 4c. The 4 is the coefficient. Or constants, and constants are numbers that stand alone. For example, c plus 2, in this case the 2 is the constant. We want to get rid of those numbers because we want to get that c, or whatever variable, by itself. We do this by completing something called inverse operations. So I do want you to write this part down. Inverse operations are operations in math that undo each other, or that undo other operations. So if you need to pause the video to write that part down, then go ahead. So let's think about inverse operations. Inverse operations means an operation that you can complete to undo something that you've done. So let's imagine that you've added 3. Well, how are you going to undo that? The inverse operation of addition is to subtract. And you can think about that because if I add 3, the only way to undo that is to subtract 3. And then later next week we're going to talk about inverse operations for multiplication, but I think you've probably figured out that the inverse operation for multiplication is going to be division, because if I multiply by 3, the only way to undo that is then to divide by 3. So we're going to model some today, and I am going to ask you to draw out the examples that you see in the pages that follow, and then kind of do with me in your notebook what I'm doing in front of you in the video. So another thing that you do have to remember is anytime you're working with equations, because you want the two sides to have the same value, if you do something to one side of the equation, you have to do it to the other because both sides have to stay balanced. So we're going to do some examples. If you want to pause the video so you can write down this example in your notebook, this one is x plus 2 equals 5. X plus 2 equals 5. Now, since we have an x, that means we do not know what the x is, so we're going to draw a box with an x in it to represent the unknown. This is what we do not know. Then it says we're going to put down 2 positives, and the way that I know that we have 2 positives is because it shows me in my example that I have plus 2. And then over here I have 5. And I know that they're all positives because there's not a sign in front of them to show me otherwise. So there is my x plus 2 equals 5. If you need to pause the video to catch up with me, do so. So now here's what you have to think about. If I want to undo these positive 2 counters because I need to get the x by itself, I want to remove these 2 counters. Well, there's 2 different ways I can do this. I could just remove this counter and put it here, and remove this one and put it here. But remember, whatever I do to one side of the equation, I also have to do to the other. So I could just remove this one and remove this one and remove this one. You can just mark them out on your paper. And I removed too many. Remove 2, if I only remove 2, then you see that x has to be equal to 3 positives. An additional way that you could do this is you could say x and 2 positives gives me 5 positives. So if you want to draw this one out again on your notebook, we're going to do it a different way. And this time we're going to make something called 0 pairs. I'm sure you might remember those from when we did positive and negative numbers. To undo a positive counter, I could put a negative counter with it, because you might remember that what's going to happen to those 2 counters, when you put a positive and a negative counter together, they cancel each other out. They completely go away. So these 2 are going to cancel each other out. You might remember that. So if I put another negative counter with this one, essentially those 2 go away again, which means I'm done with those 2. But then, because we have the equation, whatever we do to one side, we have to do to another. So we've got to put 2 of these negatives over here, which means those 2 cancel each other out, and these 2 cancel each other out. And you see that I'm left with 3 positive counters. So that tells me that x has to equal positive 3. So if you need to pause the video, go ahead until you can kind of get yourself back together and make sure that you have the exact same thing on your page as I have on the screen. Okay, so we're going to finish this up. We're going to do another couple of examples. Let's do this one. Different this time, in that this time we have x minus 2 equals 5. X minus 2 equals 5. So once again, we're going to start with an x. But this time we're going to have 2 negative counters and 5 positive counters. So there's my x minus 2 equals 5. If I want to get rid of this negative counter, I have to put a positive counter with it, because those 2 will then cancel each other out. You might remember that. And then if I want to get rid of this negative counter, I have to put this positive counter with it. And then those 2 again cancel each other out, just like before. But remember, if I do it to one side of the equation, I have to do it to the other. So I'm going to put a positive to match the positive that I put here, and a positive to match the positive that I put here. But what you're going to notice this time is now nothing cancels out on this side of my equal sign, but instead this is the answer for my equation. So if I count up what's in there, 1, 2, 3, 4, 5, 6, 7, I have 7 positive counters. So in this case, x is equal to 7. Then we can talk a little bit about how we can complete this without having to draw a picture or use count. So let's see if we can use those inverse operations that we talked about earlier to complete this without drawing a picture. I want to get the x by itself. Remember, our goal is to isolate our variable. So we want to get x by itself. So that means I need to get rid of this minus 2. So I want you to think to yourself for just a second, what would be the inverse of minus 2? What would undo minus 2? The only way to undo a minus 2 is to add a 2. So we're going to add a 2 here. And if I add a 2, that gives me 0 here, so I just have an x left on this side of my screen. Essentially, these two cancel each other out because they're inverse. But whatever we do to one side of the equation, we also have to do to the other. So I'm going to do 5 plus 2 here, and x then proves to me that x is equal to 7. And so you see that either way we go, we get the same answer. Let's do one more example, and this one is 4 plus x equals 8. And I gave you this one on purpose because I do think it's important for you to understand that just because it's written a different way doesn't mean that you cannot solve it. So let's take a look at this one with the context of drawing a picture. So we're going to draw an x here, and we're going to put 4 positive counters down, and then over here we're going to put 8 positive counters. So you be drawing this on your paper as you see me doing it. Again, this is our third example. So there we have it. And I want to get rid of these 4 positive counters, so the only way to do that is to put a negative counter with each one, but every time I do that I have to put a negative on this side. So put a negative there, and a negative here. A negative here, a negative on this side. A negative to get rid of this one, and a negative to get rid of this one. Now you might remember that that means these all cancel because there's 0 pairs, but then look here, this also cancels because there's 0 pairs. And we're left with nothing but an x. And then on this side I have 1, 2, 3, 4 positive counters. Let's do it using inverse operations. Let's see if we can do it with the inverse operations. So we're going to look at this one. A lot of people this confuses, and if it does, just rewrite it. We know that the commutative property of addition says if it's addition, I can reorder it and I can write it like this. I know that that's a plus 4 because there's not a negative sign in front of it. So if I want to undo a plus 4, I'm going to have to do a minus 4. And whatever I do to one side, I have to do to the other. So this is what it's going to look like. The plus 4 and the minus 4 make each other go away. They're inverse, which means they cancel each other out. And x is equal to 8 minus 4 is 4. So you see that either way, we end up with the same answer. We'll do this example. We won't do the picture. Let's just do the inverse operation. So in your notebook, I want you to write 6 is equal to x plus 2. This one can be confusing because the variable is on the right side of the equal sign. It doesn't matter. You can still work this one the same way. We want to get rid of this plus 2 because we want to isolate the variable. We want to get that variable by itself. So how do I undo a plus 2? I undo a plus 2 by subtracting 2. These go away, and I have x is equal to 6 minus 2 is 4. Let's do one more example, and we'll do x minus 3 is equal to 9. X minus 3 is equal to 9. So you can see what I've just done. You write it in your notebook. We want to get rid of the minus 3. So to get rid of a minus 3, we're going to do the opposite of minus 3, which is we're going to add 3. And whatever I do to one side of my equation, I also have to do to the other. On this side, all I have left is the x. And on this side, 9 plus 3 is 12. I hope this video has helped you understand how to solve equations.